Hello and welcome to GOWIN Semiconductor Corporation's webinar that introduces programming and configuration of GOWIN devices. My name is David Grugett, Senior FAE Manager for the Americas region, based out of San Jose, California. Let's see what our agenda is for today's webinar. Today's agenda includes an introduction to GOWIN Semiconductor, the GOWIN FPGA families, the embedded and external flash on our devices or external to our devices, the JTAG board that can be used to program the external or embedded flash, the different configuration modes including Autoboot, DUALBOOT, multi-boot, and how to use a golden image in those types of configuration schemes. Serial vector format will be discussed, as well as a way to remotely update your GOWIN FPGAs. GOWIN Semiconductor Corporation is a privately owned company founded in 2014. We're celebrating our 10-year anniversary. We have more than 200 employees worldwide, all working towards an initial public offering, IPO. We have worldwide locations in the Americas, the United Kingdom, and in China and in Asia. We have a worldwide network of manufacturer representatives and distributors, and we use TSMC as our foundry, and we have packaging and testing locations in China and outside of China. GOWIN's FPGA families include the Arora 5 mid-density series, the Arora 2 low to mid-density series, and the Little Bee GW1N low-density series. We compete against Lattice, Intel, and AMD in their various families of FPGA offerings, and we even have some pin-compatible solutions that can help you find a low-cost second source to your FPGA requirements. So far, we shipped over 60 million units and growing. The Little Bee GW1N family is N for non-volatile. It's using the TSMC 55 nanometer embedded flash process. This makes an FPGA look like a non-volatile instant-on CPLD-like device. So we replace a lot of the end-of-life CPLDs such as AMD's Xilinx 9500 or Cool Runner families. We've also got some pin-compatible devices to Lattice and Intel's XO and Max families. So we can help you replace or get second sourced and readily available solutions to some of these other devices for existing designs. Some of the newer designs can use these Little Bee devices in communication, security, motor control, consumer applications. We've also got low power in the Z family, a 1K and 2K. These are 28 microwatts always on solutions. Very low power for battery operated applications. We've got automotive approved in the 2K, the Z2A. So low power automotive in certain packages. We've got AEC Q100 approved in the 2K, 4K, and 9K. We've also offered the system and package solution, which is SIP, which takes the FPGA die that's instant-on non-volatile and interfaces with some pseudostatic RAM memory. We have that in the 4K and the 9K and the 2K, and we have the memory controller soft IP that will allow you to control the memory in this package. We are also part of the ARM Design Start FPGA program, which allows us to put a hardcore ARM Cortex M3 into the same package as the FPGA, along with some SIP memory. So we've got all kinds of FPGA, memory, and microcontroller-based solutions in the Little Bee family. The Arora GW2A FPGA family is a pure RAM-based process from TSMC. Its densities are from 10K to 55K lookup tables. So you can see it's an extension of the Little Bee family. We also offer some with SIP flash. So you can have in the same package the configuration flash as well as some user flash, and it's interfacing through the SPI interface, serial peripheral interface, from the flash to the FPGA. We also have some pin-compatible competitor solutions for Lattice, Intel, and Xilinx in different densities and package options. And the AEC-Q100 qualified is good for a lot of displays and cameras in automotive applications. The Arora 5 GW5A FPGA family is using TSMC's 22 nanometer ultra low power process. And with that, we can go anywhere from 15,000 lookup tables to 138,000 lookup tables. We've also got some transceivers that are good for PCI Express, Ethernet, because they can run up to 12.5 gigabits per second per channel. There's 8 channels on there, so you can go wide and fast with these GW5AT devices, T for transceivers. We also offer a RISC-V that's hardcore on the die. It's a GW5AST138. It's a AE350 platform from Andy's A25 RISC processor. And we will also do SIP with the Cortex M4, so we'll have floating point controller with the GW5AS25. So that's a 25K LUT FPGA along with a Cortex M4. The AHB bus will be connected to the FPGA fabric, so you can use the FPGA for more peripherals on your application. And once again, we offer some pin-compatible competitor solutions to Lattice, Intel, and Xilinx, and various Crosslink, Cyclone, and Spartan series. So when it comes to embedded flash, it's really only available on the Little Bee devices. The embedded flash is for configuring the FPGA, as well as its user flash for the user's application. So what are we configuring? We're configuring a lot of things. Everything's SRAM based, so it needs to be configured on power up. The lookup tables, the registers, the configurable function units need to route to each other. They also need to route to I/O pins, whether it's an input signal coming in or an output signal going out. Those I/O blocks have to have an I/O type, whether it's LVTTL, LVCMOS, drive strength for the outputs in milliamps. There's also some internal logic like block RAM, whether it's single port or dual port. The PLLs need to be configured for clocking. You might have some IP that's on there like the MIPI D-PHY receiver. You have to configure that. So a lot of things are stored in the embedded flash, and now we'll talk about the external flash. So when it comes to external flash for the Arora family specifically, because the Little Bee has its own configuration flash, this is configuration file size of how much you'll probably need in an external SPI flash. Usually SPI, serial peripheral interface, is the most common flash. But if you do other types of storage, at least you'll have to know how much each design is going to need as far as storage space. And then in this case, it's kilobytes, so just multiply by 8, and that's how many megabits you're going to need for storage for a single pattern. And double that if you have 2 patterns, and triple that if you have 3 different design patterns. But as you can see, the 18K LUT device is a lot smaller than the 55K LUT device, which is a lot smaller than the 138K LUT devices. So the more LUTs, the more bits you're going to need to configure your FPGA. So what is JTAG? It's an acronym. It stands for Joint Test Action Group. And this group was doing testing, so they created a test access port. It's a common 10-pin receptacle that has a clock signal, a data in, a data out, and a mode select signal. So those signals are common in JTAG ports on FPGA devices that you can use to program your embedded flash or configure the SRAM in the FPGA. The other thing you can do is boundary scan testing. So boundary scan is for testing the entire boards, but FPGAs use it for also programming the FPGA. And what are you programming with? In most cases, a USB cable. The USB cable can bridge to JTAG and we've got 3 cables that we offer. 2 low-cost ones, the PL USB cable version 5 and the USB dongle U to X. And then this version 4 uses an FTDI USB to JTAG bridge chip. So this cable that we have is this white USB cable connecting to this USB box, which has either an FTDI or a Go bridge chip. And then that connects to this 10-pin connector, the receptacle, which can connect to your board, basically. And then you can use software through a USB port to go in and program one or more FPGAs or do some boundary scan testing. So now that we have our board with our FPGA on it, and we have a JTAG port with a tap port, and we have our JTAG to USB cable, we need to plug that into the computer and program our embedded flash. So this Little Bee device is recognized by GOWIN Programmer. It's a tool that's embedded in the GOWIN EDA tools. You can launch it from the GOWIN EDA tool, or you could install GOWIN Programmer as a standalone. If you're in the lab and you just need to program your boards, you could do it that way. So the GOWIN Programmer will enumerate through the daisy chain. It's got a Windows driver that will drive to the JTAG port and look at what device is on there. The board has to be powered on. So the board will communicate, the FPGA device will communicate via JTAG to the GOWIN Programmer, hey, I'm a Little Bee device from GOWIN. And then it will allow you to change the operation to erase and program the flash, the embedded flash. And what you're going to program it with is the FS file, the file stream .fs that was created in the GOWIN EDA tool. So if it enumerates and it sees only one Little Bee device out there, you'll see only one device, but you can't program more than one device at a time if your board has more than one GOWIN device. So if you hit the program device icon, it will go ahead and start clocking the TCK signal and the mode select, and it will program the embedded flash with the algorithm that's in there for erase, program, and verify that the device was programmed correctly. And then it will give you on the console, it will give you a program success signal. GOWIN Programmer can also be used to program external flash memory in an Arora and Arora 5 application. In this case, the GW5AT138 was detected by the cable and will bridge to the SPI flash interface for the SPI flash memory, and it will erase and program the SPI flash memory at a frequency chosen by the user that is appropriate for the SPI flash memory. The FS file has to match the device that you're trying to program. Little Bee GW1N FPGAs are really SRAM based FPGAs, so they need to be configured on power up. Configuration mode is determined by the mode pins 2, 1, and 0. And the most common, of course, is Autoboot using the embedded flash. And if that flash gets corrupted, using DUALBOOT, so you have a golden image backup. But there are other ways to configure the SRAM. You could use JTAG with an external host, like GOWIN Programmer. You could use I2C host if the device supports I2C. Not all of them do. And then you can use, on some devices, GoConfig, which creates an I2C port on some devices. There's also host-based CPU modes that can use parallel bus or serial buses. There's also master SPI, where you can use an external SPI flash and not use the embedded flash. So those are the ways that you can use the mode pins to configure the SRAM logic in a GOWIN Little Bee device. Arora and Arora 5 do not have DUALBOOT or Autoboot support for configuration. That's because they don't have embedded flash. So the external SPI flash is usually the most common way, the master SPI interface for both configurations, where mode pins 2, 1, and 0 are set to all zeros for the 2A device and 0, 0, and 1 for the 5A device. Now the 5A device can support not only single master SPI interface, but dual and quad SPI interface. This is great to get you to user mode faster because the Arora 5 devices are higher density. So the external host configuration is still available in JTAG for both families, as well as a external host CPU for both parallel and serial interface. Autoboot is available only on Little Bee devices because they have the embedded configuration flash. On power up, if the mode pins are set to 0, mode pins 2, 1, and 0 are strapped to 0, then Autoboot configuration mode will engage. The power on reset will occur with ready and done status pins staying low, and then when the configuration from flash to SRAM is done, then the done and ready pins will go high and you'll be in user mode. Little Bee Autoboot configuration time is dependent on the density of the Little Bee device. If it's a 1K device and the loading time, which is the default in the bit stream, is set to 2.5 megahertz, then it'll take about 34 milliseconds to load. And on a 9K device, it would take about 178 milliseconds to load, and that's to get to user mode. Now, if you want to speed that up, you can change that in your bit stream under the configuration bitstream syscontrol loading rate setting. So you can see the default's 2.5 megahertz, but if you change it to 31.25 megahertz, the onboard oscillator will load the bitstream a lot faster. And in this case, it'll load a 1K device in 3 milliseconds, and that's at 31.25 megahertz frequency. And a 9K device will be only 14 milliseconds to configure and get into user mode on a 9K device. DUALBOOT is a remote upgrade solution for Little Bee. The last thing you want is to upgrade a Little Bee device and corrupt the embedded flash, and then the device will not boot up and it's a brick dead in the water. So if you use a external SPI flash to boot from, then that external SPI flash, if it gets corrupt, then the embedded flash will be your golden image, and you can boot and recover from your golden image that's in the embedded flash. So you do all your upgrade work on the SPI flash, and if it accidentally gets corrupt, then the embedded flash with the golden image will be there to get you back into user mode. Multi-boot configuration mode is for the Arora and Arora 5 FPGA families. It's a form of master SPI configuration mode that has multiple working images and a golden image, all stored on a single external SPI flash memory device. On power up, the FPGA will read the first bit stream at image 0 and use that until the reconfig end pin is strobed from high to low. Then it'll jump to the next working image, and you can use that image until the reconfig end pin is strobed from high to low. Now you can have as many working images as you need in your application or that the external SPI flash can store, but the last image is called your golden image, and that will be your fail-safe image that will get you out of a brick or dead in the water scenario. When using multi-boot configuration mode, each working image needs to have a multi-boot bitstream file generated that has the jump to address for the next working image. In this case, we can go to the bitstream feature syscontrol SPI flash address, which is the jump to address for the next working image. So in this case, we jump to working image 1 from working image 0. And then we'll have to create the next working image file. We'll have to have a jump to address to 2 for working image 2. And then you can have your golden image file set to maybe the last address in the SPI flash memory. So once you have each working image programming bit stream, which has the jump to addresses, you can program those files into each address of the SPI flash memory, the external SPI flash memory. You can do that through GOWIN Programmer. And when you program it, you can set the start address on the SPI flash memory. The first one, of course, is going to be at address 0, and that has a jump to address of 1. So you would put the next working image at 1 with a jump to address of 2. Now, in this example, 2 is going to store the golden image, and that's the image that you never reprogram after you don't use it for remote upgrade, that address. So if you ever get to image 2, which is the golden image, then it will notify the remote upgrade system, you need to go back to working image 0 and 1 and reprogram those and get those fixed. Now, should you reboot the system and you still haven't fixed working images 0 and 1, golden image will boot and do it again, saying you got to fix image 0 and 1. But until it gets fixed, it's not going to jump to address 0. And if it does, then it's going to fail to reboot. But once you successfully get to image 0 working again, then you'll never get to the golden image unless images 0 and 1 are corrupt. So that's a fail-safe proof system for Arora 5 and Arora 2. So we've seen why a golden image is really recommended when you do remote upgrade in FPGA systems. So the golden image, by definition, is a usable bit stream that will get you into user mode. It's one that is not corrupt. There's no once it's programmed in any kind of system, then you do not touch it. It's part of the remote upgrade notification system that says something's wrong with the images, and it's a golden image that should work all the time, and it's usually stored in memory that is secured and never touched and non-programmable, etc., etc. The bit stream is programmed and verified before deployment and never reprogrammed during deployment. So the golden image it's very necessary for avoiding non-operation bricking or dead in the water type applications, and it can be included in recovery mode so that you can reprogram the corrupt work images and work and protect fault intolerant fail-safe type applications. Use all you want. It has to be a fault tolerant system, otherwise you're going to brick and be dead in the water. So FPGA configuration modes that typically deploy a golden image are the dual boot and the multi-boot applications. Dual boot for Little Bee and multi-boot for Arora families, Arora and Arora 5. So FPGA applications that typically use dual or multi-boot have a remote upgrade application. SVF, serial vector format. What is it? It's a way to combine the programming function calls and the FS file, that's your FPGA bitstream design, into a single file, and the SVF interpreter library and the software program, which is usually an SVF player, will run these SVF files and do things like program embedded flash or configure SRAM, all via the JTAG port. So that's the serialization of it. The JTAG is serialized. Purpose of the SVF is for automating testing, as well as used in remote upgrades, so that you can pre-engineer your remote upgrade and then upgrade the system remotely via SVF file without having to have a human there running the programmer software and using a USB cable to JTAG to do the updates. So all our devices in Little Bee, Arora 2, and Arora 5 are supported with SVF file generation in our programmer software, and you could do it for configuring SRAM or programming flash or embedded flash or external flash. It's easy to create an SVF file using Goen Programmer. You simply select the desired device and operation and FS file, and then right click and it will give SF file create as an option. And when you click on that, then it will create the SVF file. Each of those SVF files that were pre-engineered and generated with GOWIN Programmer follow a command standard, and those can be used on all of the SVF interpreter players that are out there. There's some on GitHub. There are some that can be used for manufacturing and testing, and there are some that can be used for remote upgrades embedded in SoC processors. So there's all kinds of applications for using SVF files. There are a lot of interesting remote upgrade applications using novel mediums to transport the new bit streams out to the deployed system out in the field. Some used wired systems like wired Ethernet, or wired systems using PCI Express that are closed systems. Wi-Fi wireless, with Zigbee wireless, Bluetooth wireless, satellite, cellular phone. They're all using compression to lower the FS size of their bit stream so that they don't have to spend a lot of time transmitting a large file. Some of them implement SVF players embedded in SoC designs, and all they have to do is send an SVF file and then play that in the embedded SoC player and update their systems that way. Some people will use controllers or processors and just send the FS file to program the configuration flash. Sometimes it's SPI flash. Sometimes it's the embedded flash in a Little Bee device. We've also got some people using controllers and processors to just configure the FPGA SRAM on power up. They're using the CPU mode, and then all they have to do is send the FS file, and the CPU will bit bang the file into the FPGA on power up. Some have security concerns with using remote updates, some type of man-in-the-middle theft of their bit stream, or a hacker modifying the bit stream. So with that, we have security solutions with encryption. Right now it's available on the Arora and Arora 5 families, where you have a hex key that's programmed into the FPGA, and only bit streams that have the same key will allow the FPGA to program. So even though they might have stolen the bit stream, they can't use it on any FPGAs unless that FPGA has the key programmed into it. So that makes it a useless bit stream that they've stolen. And for security bit, we have that enabled for all devices. The security bit allows the user to configure the FPGA, but they can't read back out what was just configured in the FPGA. So that's another level of security that people use when using remote upgrade applications. And lastly, the Goen FPGAs and applications that use remote updating most typically use some type of dual boot or multi-boot, but they do it with a golden image, so that if they do an update and it does get corrupt, they can recover with either a dual boot or a multi-boot golden image application. So that doesn't leave the system that's deployed unusable. It can at least be upgraded in the near future.
All right. Thank you, David, for that presentation. We're moving to the Q&A portion of the webinar. Please send us your questions and we will answer them now. If we run out of time, we will answer those questions through email. Okay, so the first one I have here, David, will be, is the GW2X device in your programming cable available as a standalone device?
Oh, absolutely. Goen has an ASSP program called GoBridge, and that was used in the cable, the version 4 or version 5 cable of our USB to JTAG. So you could easily put that device, it's in a 32-pin quad flat pack, on your board, and then all you have to do is hook up a USB cable, and it'll convert from USB to JTAG. So it uses a JTAG open source driver, and that should be easy to implement in your design, your embedded design.
All right, got it. Next question, where can I find info for Spartan 6 compatible packages? They're specifically interested in whether there's a QFP offering.
Right. Well, we have a code on the package. It'll be the letter S for Spartan. And if you go to the Arora family, the Arora 2 family has some specific packages that you could see now. If you don't see a package that does have Spartan 6 pin compatibility, work with your local GOWIN FAE, and we can get you a device that's as closely matched to that. So that may be the situation with the QFN package.
All right, got it. Quick follow-up for that one is, will there be a QSPI config option for bigger devices?
There is for the GW5A Aurora 5 family. I alluded to it that it supports single SPI, dual SPI, and then quad SPI interface. So that allows you to configure the larger devices a lot faster.
Awesome. Next question, can the remote upgrade include new firmware for the embedded controllers?
Absolutely. The embedded controller, the one that more specifically I'm alluding to, is the Cortex M3 on the GWN SR4 device. The configuration flash includes the compiled code for the Cortex M3 in the configuration flash, and then it copies it into the embedded block RAMs on PowerUp. So what you can do is, if you change your code, you can go in, and with the entire FS file, it'll have the combined new update code, and then program that into your GWN SR4 device, and then you'll have the upgraded code, the embedded code for your processor, as well as you can modify anything with the FPGA fabric.
All right, great. Next I have, how much are the Goen EDA software and Goen programming software tools?
So all the software tools are free. We have a requirement that you have a license, but the license is free. It's based on your PC MAC address. So when you download the software from our website, you can also request a license for our EDA tools, and the programmer tool is embedded in the EDA tool, but you can also download just the programmer tool. We have both Windows and Linux versions. That's available without a license. So you can put it in your lab and program some boards without having to load and install the entire Goen EDA FPGA Designer software. But the EDA software is including synthesis, place and route, and interfaces to third-party simulator tools like ModelSim's third-party tool, or Synopsys. We also work with Metrics. They have a decent cloud, which is pennies per minute simulation. So you can simulate from your computer, but the simulation would be done in the cloud. You don't need to install simulation tools. So the key thing is that all of our tools are for free. The development boards are you have to pay for, and the cables, the programming cables, you have to pay for. But as far as FPGA tools and Cortex and RISC-V IDE development tools for your C code, those are free. You need a license for those, but they're readily available from our website.
Okay. On the topic of the programming cables, where's the best place to get those? Where can I buy them?
Well, we have a global network of distributors that have online stores. They're selling both the version 4 and 5 PO USB cables. Um, just in the Americas alone, I know about Rutronics uh, and Edge Electronics, Mauser.com. And then we have for educational purposes, a low-cost dongle that has our Goen U2X cable, our USB to JTAG dongle. It's available on the Amazon.com store. You can just search for U2X dongle, and that's more for educational, low-cost applications. But you can use it in your development. It's got the U2X chip on there. That's limiting to 1.3 megahertz for JTAG clocking.
Okay, awesome. Can CPU mode also support JTAG?
Yeah, the processors are using general purpose I/O to create a bus to program FPGAs, but then you can also use those general purpose IOs as a JTAG port and bitbang the port with your FS file. The code that is needed for the operating system can be attained from your local Goen FAE. And we've got C code for Raspberry Pi, as well as like STM type controllers.
Got it. And going back to the vendors you mentioned, would any of them have any problems delivering parts to the market?
So as far as the distributors know for distributing Goen devices, but if you're referring to our pin compatible replacements from other vendors like Lattice, Altera, and Xilinx, during COVID, there's a lot of problems getting those parts, and including the FTDI chip, which is why we created the GoBridge chip. But we have a lot of pin compatible or close to compatible parts because the lead times were long for those other vendors, Lattice, Goen, or Lattice, Altera, and Xilinx. Goen had readily available parts through their distributors to replace a lot of devices that they couldn't get. And if you can't ship a product, then you're dead in the water, as they say.
Got it. We're kind of already on this topic, but as far as pin-to-pin compatibility goes, is that ready to go, or does it typically need to be developed for a new project?
Right. The pin compatibility is the power and ground and the I/O pins, but the actual bit stream needs to be reconfigured with the source code needs to be synthesized, placed and routed, and then create a new FS file for our specific device. But there's minimal changes on the printed circuit board that has to be made, especially if they're pin compatible. But the key thing is you have to create a new bit stream for the Goen device. They're not bit stream compatible. They're pin and I/O compatible.
Nice. Okay, thank you. Next up, are there any security options to protect IPs, specifically in Little Bee devices?
Yeah, when you're creating your own IP, all our IP is free in our tools, but a lot of them are obfuscated. We have an option in hierarchy where you can click on the code that you want to obfuscate and pack it, and so it'll be packed in your design so that no one can steal your source code. And then when it comes to creating the bit stream, it'll be embedded in the bit stream, and you can secure the bit stream with the secure bit. And then if you want to secure the entire chip, you can have especially in Aurora and Aurora 5, uh, a key so that the bit stream has the key, and then the FPGA has a pre-programmed key in it, and only bit streams and devices that have the key will load. So that's a way of protecting your IP as well as your design, entire design, after it's been deployed.
All right. I have one here that says, do our starter kits and dev boards have user inputs like buttons and LEDs?
Oh yeah, absolutely. We have a lot of pins going to pin headers, so you can connect to those, as well as LEDs and push buttons for reset or system applications. We have a default waterfall LED waterfall design in the board, so you could get that design from us. We also have a lot of reference designs that you can put on the boards and utilize those header pins and maybe predefined pins to Ethernet PHYs or to HDMI outputs or MIPI connectors for cameras or MIPI connectors for displays. So a lot of the boards have uh, LEDs and push buttons on them as a basic uh, type of interface, and then there's the header pins for your application.
Okay, great. Does GOWIN provide schematic and PCB layout symbols?
Yeah, they're available on our website. We have them in separate schematic files for not only our device packages, but also our eval boards. We have in OrCAD, we have the pads that you could use for the symbols to put on your printed circuit board, and then we also have the symbols you can put on your schematics, so that you can create your schematic and your Gerber file using package symbols as well as pad symbols.
All right, next up, do we have any dev kits with HDMI input or output?
Yeah, there's plenty of boards through Goen as well as third party that have HDMI connectors. For us, for the IP part of it, we have the DVI currently, and we are going to have the full HDMI with audio IP. But you can use a third-party HDMI chip that'll have both the HDCP type encoding as well as audio and video on it. But there's a lot of boards out there that have the HDMI connector on there so that you can use displays. You can go out to TVs or monitors.
Okay, great. You kind of already went over this, but do you mind going over what simulator options we have?
Yeah, we have third-party simulator options, so they're not included with our EDA tools. We've got the Model Sim, Active HDL, Synopsys, and Cadence, and then our third-party simulator in the cloud with Metrics. Metrics is a in the cloud simulator. You pay pennies per minute while you're simulating, and it's gonna right now. It's you have the link to create a Metrics account in our tool, and then do all your simulation in the cloud. But future releases will have a form of simulation in the tool, but you'll still need a link to the cloud to verify you have a Metrics account, so it can charge you while you're using the tool on your computer.
Okay. Got a couple more here. Is our toolchain compatible with Linux?
Oh, absolutely. We've got Linux and Windows support. Go to our website and you can download each and then also request a license for each. And this is including the programmer tool.
Okay, great. Now, last question for you. Is it possible to read out the user flash content with only our GW1N device using the Goen JTAG USB cable?
The flash device can't be read out, but what's in the SRAM can be. So when you power up, it configures from the flash, embedded flash, to the SRAM. But we'll only read that out if the security bit is not enabled. So in our tools, the security bit is defaulted enabled for the bit stream. But if you uncheck that because you want to do a lot of development. But then when you ship your final bit stream that goes into production, you can enable that security bit, and then you wouldn't be able to read that out from the SRAM.
All right, looks like that's all for our questions. Thank you everyone for participating in today's webinar. A recorded video of this presentation will be available by tomorrow, and you'll be sent a link directly to the email you used to register. This concludes the webinar. Thank you, stay safe, and have a great one.
Cheers.